everyone. Welcome back from the break. We are going to talk about connected vehicles in Florida, and I'm really excited to hear this panel. I'm going to be in Florida at the end of April, so thank you all for being here. It's my pleasure to introduce Marcus Welz. Did I pronounce that correctly? Yes. Okay, great. That makes me very happy. He leads the intelligent traffic systems business at Siemens and is a world leader in traffic technology and advanced software and systems to modernize and improve urban data. He's been with Siemens since 2001 and has held a number of strategic business direction and management roles, both in Europe and the United States, and has served as a senior vice president and head of global sales and project management at Siemens AG, headquartered in Munich. He has a BA from Munich University of Applied Science and a Master of Science degree in energy engineering from, I will let you pronounce the rest of it.
It's from a nice university in Karlsruhe.
Perfect. Thank you very much. Thank you so much for being here.
No, thank you. I can't hide my German accent, but I think that will be okay. But I'm actually Austin-based, so I'm quite glad, let's say, to host this panel. Let me first introduce the other panelists here. So I'm very glad I start with Bob Frey here on the very right. So Bob Frey is the planning director of the Tampa Hillsborough Expressway Authority, and he's also the project manager for the connected vehicle project, which is currently in implementation in Tampa. Bob has, I think, more than 25 years of experience working in local, state, and tolling agencies, and with that, let's say, implemented a lot of innovative mobility projects, and one of, let's say, the lighthouse projects definitely is the connected vehicle piece, what we will talk a lot about today. I'm also glad that Steve Novosad here is joining. So Steve has, let's say, an unmatched capability and experience in terms of, let's say, ITS, connected vehicle, and also software deployment and system deployment. It's HNTB. He's based out of San Antonio, but he's also now the lead system engineer for the Tampa connected vehicle project. And I think his experience, I think it goes back for more than 32 years in the industry and in this system deployment. So we have a lot of experience here on the table. So I would also like to invite you guys, let's say, to ask some questions. Maybe to set a little bit the scene at the beginning, I like to give you a glimpse of what we are doing here. And I mean, it's always quite exciting for me when I get the opportunity to talk about innovation. And I would argue there is no industry which is embracing innovation like the transportation industry. And Siemens, I mean, we have, let's say, quite a broad experience. We have been driving towards the future of transportation throughout our almost 160 years of history here in the United States. We have presented the first electric railway system in 1879. We have constructed the first underground subway system in 1896. And actually also the first traffic signal has been and is still today controlled by a Siemens traffic controller. This is out of Cleveland, Ohio. So I would argue we have, let's say, seen a lot of changes in our industry. Some of you may have hailed a car to come here today, and in some of you even see self-driving vehicles, sometimes even here in Austin on our roads. But while all the technologies are getting smarter, there is still a big problem looming, which is that there are more than 33,000 people which are killed or who are killed on US roads every year. This is actually unacceptable. And there is an average American spends 1 week a year stuck in the traffic jam. Talking about myself, I'm here based of Austin, and I have a 20 miles. I drive every morning 20 miles from my home to the office here in Austin, and every night my commute is a complete crapshoot. I often have to leave, let's say, the freeway and find an alternative road where everywhere is congestion. And this type of frustration may come to an end because in the future, the technology is there where, let's say, if cars in front of me on I-35 hit traffic, that actually the infrastructure would recognize that and give alerts to other road users and even the ability to, let's say, redirect traffic in order to not make, let's say, those congestion even worse. So the good news is that the work has already begun. And just to give you one more example, which is not directly in the connected vehicle arena, we are, as Siemens, just implementing an, we call it adaptive control system in Ann Arbor. So what we are doing there essentially is we're making dumb traffic signals smart. So it's a real-time adaptive system where we are changing traffic patterns in real time according to the occupancy rates on the streets. And the system is working. So we have reduced travel times depending on the time of the day and the day in the week of up to 20%. And we have done a recent study. Actually, it's not done by Siemens, but by an independent engineering office, so that we have, let's say, achieve those 20% of reductions in delay, which is great. So conventional wisdom would say, why don't we just take these systems, roll it out across the country, and incrementally improve them, and all our problems are done. But I mean, as a provider of a leading adaptive system, I'm here to tell you this is like me saying if I work very hard at jumping, one day I will be able to fly. That won't happen. So we need to think a little bit differently, and we need to think a little bit broader on that. And what really inspires me is, let's say, what we can do if cars start talking to each other and cars start talking to the infrastructure. So it won't be just the cars who are getting smarter, but also the infrastructure like traffic signals, street lights, road sections, intersections, who will be able to talk to vehicles, public transit, or even to pedestrians. And let me talk a little technical for a second here. So with the connected vehicle technology, we will, let's say the cars are transmitting 10 times a second its position, direction, speed, latitude, and longitude. And the infrastructure, on the other hand, again, 10 times per second, it can respond, for instance, by giving harmonized speed recommendations to the driver in order to traverse smoothly to intersections, or giving alerts like wrong-way driving, curve speed warning, red light violation warning. It's a technology, so we're talking about connected vehicle technology. It's a technology where the US DOT says it can prevent 80% of the unimpaired vehicle accidents. This is quite massive, this statement from the US DOT, and without now commenting on that number, I think the opportunity is really huge, what this technology could bring. And it's not only, let's say, the future, it is something which is happening right now. We are currently in implementation or there are 3, let's say, pilot sites in the United States, so in Tampa, Florida, in Wyoming, and in New York, where this technology is put from small pilots into large-scale real-world application, where a lot of use cases and applications will be realized on the street. And now I think this is a perfect, let's say, handover to our panel, because here Bob from THEA, from the Tampa Hillsborough Expressway Authority, is actually the company and the authority who is implementing that on behalf of the US DOT in Tampa. So I would probably give the first question to you then, and let's say, tell us how you approach that project, Bob.
The first, just turn it on. It's not turned on. It's not turned on. The first thing I guess I'd like to comment on is that I work for a toll authority. We're an independently owned public agency, and we've got a history of innovation. 10 years ago, we finished a elevated reversible segment that goes from downtown Tampa out to Brandon, which is bedroom community, and every day we switch it back and for the traffic. We're the first in Florida to also go all electronic in our tolling. We've also have several back office image review type of pilot projects. We ran pretty much the first as well. So I guess the point I'm trying to make is we have a history of innovation. Siemens I was listening to Marcus talk a little bit about where they came from, and it seems like that culture of innovation needs to be there, and it needs to be there from the top. My executive director had the vision to actually look into connected vehicles. We were sitting down having a conversation about it. And to be honest with you, I thought it was a flash in the pan. And we were at the time we were working on a image review processing change in logic from a company over in Scandinavia that was approached us, and there was an engineer that was in the room, and he interrupted and he said, "Oh, you know, connected autonomous vehicles. I worked on my first project when I graduated from school in 1974 for Mercedes in parallel parking." So that right there sort of hit me, because the automakers have been, you know, looking at this since 1974. They actually had programs up and running on this technology. The second thing that really changed my view on autonomous connected vehicles was when I went out to the Transportation Research Board project out at Silicon Valley for the Autonomous Vehicle Conference. And I saw the money involved, the companies, the size of the companies, and the investment that's been made. So you take that type of commitment and of resources with that much time that they've been trying to do it, and I got news for you, it's coming. There's nothing we can do to stop it. It's sort of a little bit of a funny story how we got involved in the CV pilot. I decided that we were going to go for that, and I ran into Mark Rogers from Siemens at an ITE conference in San Key, and about 2 in the morning at the bar on the back of a napkin, our proposal was, you know, basically hashed out. So there were some good points that came into it and some other lessons learned that we learned. But my point is, how we got involved in this is through a culture of innovation, looking at what the opportunities are out there, and then identifying people who can get it done. Did my research on Siemens. This was a solicitation. This was not a typical procurement for us. So we were almost like being a consultant, being on a team, putting together a team to put together our proposal for US DOT. So we started looking around. H&TB was our general engineering consultant, and they had a background in that in Ann Arbor for the safety pilot. My connections working with Siemens was the same way. And so we started, Booz Allen was involved early on because of security, Global 5. We put together a team that not only was involved in the project, but also had the depth of resources to get it done. As a toll authority, I approach things a little differently than the rest of the people around here. The CV pilot is one thing of 9 that I got going on. We're building a 2-mile bridge right now where I've got a trail that I have to build 5 pocket parks on. I'm building a dog park. I got soccer fields that are being built underneath an Expressway authority. This is one project of a bunch. So in these other projects, we've had a lot of startups come up and talk to us about these great ideas. And we tried one, and 3 months in, we had to shut it down because they had a great idea and the technology worked, but they didn't have the depth to get it done. And so that lesson stuck with me, and I wanted to make sure that who we were putting together as our team had the depth, the bench strength to get it done and be successful. So that's how we put together our team. There were 52 applications. They selected 3. We were one of them. We were a dark horse in this. Nobody expected that we had a shot to win it. So I hope that answers the question of where we came from. It was from a strong executive board commitment. Our proposal alone was $100,000. I mean, my board had to approve $100,000 for a proposal on a CV pilot for future technology that we really were told had no shot at winning. So think about that. What type of commitment do you have to do that and to find that? That, to me, is special. And, you know, it's funny, I was watching the news last week, I think it was, and they were talking about Sears. And they brought up a great point. Sears should have been Amazon. They were set up first with the catalogs. They had everything going. They were a national institution. But they stopped being innovative. So from our perspective, you got to stay on the front end of innovation. And we're hoping to see that the safety benefits and efficiency benefits we see from the connected vehicle technology make our road more attractive to users and allows us to move people through in a more safer, efficient manner. And that's pretty much how we got here.
And I think there's some great points, and I want to broaden a bit the discussion also involving Steve, and maybe Steve, you could also from your perspective tell a bit on how you get engaged in this pilot project for connected vehicle, and then also maybe a bit in general on, let's say, what is your vision on connected vehicle technology going forward across, let's say, also on other sites across the country? Do you see this is a technology which will be rolled out further and has a lot of potential, and what are probably the risks or the setbacks with this technology?
Sure. Thanks, Marcus. So my history goes all the way back to 2003, when this technology was known as Vehicle Integration Initiative, or VII. It was hatched originally as an idea by USDOT. They had a public meeting on it. They brought the automakers in, and the goal back then was they were going to deploy 100,000 hotspots across the country, and then every car would be equipped, and the cars would be basically network nodes. They'd be able to communicate with each other and then pass information off to the infrastructure. And so the USDOT got up there and said, hey, this is great, this is where we're going. The automakers are on board, and the automakers got up there and said, we don't know what you're talking about, we're not involved in this, and we're not going to be until you deploy the infrastructure. Well, then the USDOT said, we can't deploy infrastructure, we have nothing to use. So it kind of went into a stalemate for many years. The USDOT continued research. They poured over $500 million into it. And it's come to fruition in 2012, I believe. They launched what's called the first safety pilot, which was in Ann Arbor, Michigan, which was to test out the vehicle-to-vehicle communications. In around 2009, the automakers finally got on board internally with themselves and formed a consortium called the Collision Avoidance Metrics Partnership. Doesn't really sound connected vehicle-like, but it's called CAMP. And there's 17 automakers now involved in that, and what they did was they shared ideas and technology so that they had a common language they would speak between the vehicles. So if you're driving a Mercedes, a Ford, a Chevy, it doesn't matter, they all speak the same language. And that's the key, right? Every car has to be able to talk to every other car, not just their own. So they came to that conclusion. They've demonstrated that technology at some conferences. The USDOT funded this project to do a pilot of about 3,000 vehicles. It had success. I don't know how many of you, well, first off, how many know what NHTSA is before I even say NHTSA? No one. One. Okay, the National Highway Transportation Safety Administration. It's the people who mandate seat belts, airbags, the kind of stuff, the safety systems in your car, along with a lot of other stuff. Last year, well, not last year, I guess in the last few months, they put out a new rulemaking that's out for comment right now that's going to require this technology in the car, starting approximately in 2020. It hasn't become a rule yet, but everybody expects it to. So we've gone from basic research to a big lull to back to research, and now we've got this rulemaking out. And the rulemaking was really based on the data that was gathered during this first pilot. The pilots that we're talking about now, the connected vehicle pilots, their focus is really supposed to be on the vehicle to the infrastructure and the infrastructure to the vehicle. And in our case, and in New York's case, we're also involving smartphones. So we're doing a multiple connection of different technologies and different communication mediums. So that's kind of up to date on how I've been involved. I've been in committees. I've been in the certification world. It's one of those things as a private sector person, it's like, what do I do? Who's going to pay me to do this? Because, yeah, we're doing research, but there's no real world work. Well, it's starting to come, slowly but surely. And, some of the stepping stones that we have to go through, though, is, all right, so let's say they mandate this in 2020. So it takes, I can't remember, 10 years for the fleet to turn over? So in the meantime, before you have, will we ever have 100% penetration of connected vehicles? We could argue that. But what we will have is an adequate penetration to be able to do the kinds of safety systems that we want to do and get the information out. The problem is, while we're getting there, how do we make it work? If I go out and buy a car that's equipped, by the way, the 2017 Cadillac that's now being sold, the CTS, has the technology in it. So you can go test drive one and have them demonstrate it for you. But if I buy one, but you don't have one, how can we do these things? So one of my new platforms is, for now, we have to rely on not only the connected vehicle technology to give infrastructure the information, but we also have to use our existing detection technologies and signal systems and such in order to supplement that while the connected vehicle world matures. As it matures, our dependence on this will lessen, but at least we have to have that balance. Otherwise, it's never going to get jump-started, never going to move forward. It will, but it just, people won't want to use it because it's, well, I still had my collision because that car wasn't equipped. Well, okay, but if we had existing technology that we were using, maybe we could have avoided that. And that's part of what we're doing in Tampa, is looking at how do we use existing detection technology and systems that are out there as a way to make it look like we have a nice penetration of vehicles. So, you know, that's, to me, the future of that is we got to do that. And then as we get out there, to me, connected vehicle is the foundation for everything else that's going to come in the vehicle world, including autonomous vehicles. And I'm sure there's a lot of Google fans in here, and they've seen the Google car. And yes, it's autonomous, and it's driven however hundreds of thousands of miles with minimal wrecks. No issue with that. My issue with them is they say they don't need to be connected to anything. So I have a challenge then. You take your Google car that's not connected to infrastructure, and I'll get in my autonomous car that's connected to the infrastructure. We'll go get on 35, or we'll go out to, I don't know, north of town on 35, and when my car gets a message from the infrastructure that 35 is shut down at 290, my car's going to exit and take me to a different route. The Google car is going to drive right into it if they're really not connected. So that's something to think about. And that to me is the foundation of why connected vehicle has got to be the foundation for this.
Maybe just a follow-up question. Do you think that there is what would need to happen that more and more cities are also from the infrastructure side investing in this type of technology?
That's a really good question, because while the US DOT can mandate what goes into vehicles, they can't mandate what happens with infrastructure. That really now becomes a local agency issue, and we're not talking about like TxDOT. We're talking like the city of Austin or the MPO here, or smaller agencies that have limited budgets, and they can't, you know, many small cities can't even afford to upgrade their signal systems. Their signal system's 25 years old. How are we going to put this new piece of technology to it? So that's a challenge that's coming. And I think what's going to have to happen is that there's going to have to be a recognition at the local level by the local governments that in order for us to make our streets safer, and not just the vehicles, but for cyclists and pedestrians and the whole thing, then if we're going to achieve this goal of being a safe city or a mobility city or even more green, then we have to invest in this infrastructure. And I think, as quite frankly, as the older generation starts to roll out and the newer generation starts to come in, you're going to see that happen. And we're going to have to find ways to get that money so we can upgrade our infrastructure.
That's exciting. Thank you. Bob, I would just, I mean, we have a lot of insights now on how you've seen that, let's say, from an agency perspective, how you see it, let's say, looking at the industry. How do the citizens of Tampa look at this project?
So far, from the citizens' perspective, we've had, it's been very well received. We actually have had people calling up trying to see if they could take part. So the citizens seem to be a little bit ahead of the local governments and the budget approval authorities. Something I've noticed over the last 2 years is most of the conversations and the conversations that people want to have are all on the technology side. It's all they want to talk about is the technology. Well, the people who are approving the budgets that are actually going to be implementing this technology don't really care what technology it is. They're looking for functionality. Functionality, reliability, return on investment, maintenance cycles, and those boring things that nobody wants to talk about, but that's what drives your budgets. For a connected vehicle, autonomous vehicle solution to bump a transportation solution that basically has almost 100 years of success behind it. I know that if I put a right turn lane in, I'm going to be able to move X number of vehicles. We need more information coming back from the technical side on what are the benefits, how is it quantifiable, how can we do this, and move that money from one project to another with some sort of assurance that we're actually solving a problem that we're trying to solve. And that's something that right now I'm not hearing. People want to talk about security. Oh my God, they'll go on for 4 hours about security. I got news for you. From an agency perspective, it's a specification and a procurement. The private sector is going to be one who's going to be dealing with that. We have our consultants that will review that spec and make sure that it meets the NHTSA and USDOT requirements, but that's it. So, I mean, so we have conversations 5, 7 hours about security. We're just looking for functionality, performance measurement that we're able to hold it to. It needs to reach that point of maturity where we could talk that type of talk and that type of discussion for it to start moving into the budget cycle and start replacing existing technology with new technology that can make this. And that right now is what I see as being the part of the conversation that's no one's talking about. We're all excited about the technology and the potential benefits. How do we get it into the transportation planning and funding cycles that you see and be able to make these decisions?
So I think the beauty of this technology is that we can solve specific problems already today, like, let's say, increasing the safety on the road and increasing efficiency. But also, if you think further, I mean, let's say with connected vehicle technology, it is not only connecting maybe the infrastructure to the car, also the cars themselves ultimately will be a sensor in order to make, let's say, traffic management on a holistic way more efficient. So today, let's say, cities are investing a lot of money on traditional detection, cameras, loops in the ground in order to know where the cars are, and finally the cars will actually tell us where they are. So this by itself will give a huge optimization potential and also road user-centric applications in order to optimize trips. But it can also go beyond that. It could also go, let's say, if you think simple things like, I mean, if you're driving through an area with a cinema, and that you could even get advertising on that. Whether this is, let's say, a part of that type of connectivity which will ever be realized because it's safety relevant, I think the future has to show. But I mean, there is actually not, it won't be from the technology perspective only limited to that. So these type of connectivity with the infrastructure, which is today focused on safety and efficiency, if you're driving through an area where probably there is not such a, let's say, critical intersection, for example, but there is a nice cinema and you could maybe get such information. So all of that use cases may be a bit futuristic today, but are possible. So I think we are on a very interesting path, let's say, on connectivity, connecting infrastructure, connecting vehicles, connecting pedestrians in order to make them traverse safely to downtown. And the future will show, let's say, how strong this technology will change our life. But I also want to open it up. I mean, I think we have a couple of minutes left if there are some questions from the audience to the panel.
So the way it works, there are the devices that are called roadside units. It's kind of a generic name, but and they communicate with the cars using a communications technology called dedicated short-range communications, DSRC, 5.9 gig. Okay, and you know it's under siege too, right? So the flip side of that is then the RSU can connect. If it's at an intersection, it will connect to the signal controller and be able to get signal timing information from the controller in terms of red, yellow, green countdown information, and can broadcast that out to the cars to let people know that you got 10 seconds of green left or whatever it might be. It also can connect back to a traffic management center, as Marcus was saying, and that can be through fiber or wireless or whatever the agency has available, and get that information back to, get it back to the traffic management center so that they know what's going on in their region. But it's really, I mean, the box may be this big. Okay, so they call those OBUs, in-vehicle units, or aftermarket safety devices, or integrated safety devices, depending on your flavor. Those things are literally like this. The one we're installing 1,500 in private vehicles. We have a company under contract that is basically a tier one aftermarket installer, if you will. Their company's name is Brand Motion, and when they're done with your car, you'd think it just came off the factory line. And so what they're going to do is they're going to install the devices on there. They communicate obviously with DSRC. Our particular interface is going to, HMI is going to actually be a mirror. We're going to use a little 2x3 square of the mirror to broadcast warnings if they're about to collide with a vehicle or a pedestrian or whatever it might be. And then we're also going to have Bluetooth speakers that'll give an audible warning so that if a car or a person's coming from the left, they'll get a chirp as well to let them know they should look that way. But that's where the OEMs are actually very secretive when you start talking to them, because that's how they're going to differentiate their car from other competitors and be able to say, buy my car because I have more bells and whistles than this guy does.
One thing I'd like to add to that is one of the differences between the pilots that are being done by US DOT right now. In the future, most cities and counties that operate the signal systems will only be dealing with the roadside units. We pretty much have to work on both sides because we have to get it in there. The US DOT CV pilot program is about generating data and seeing what how this technology performs against performance measures to do that. So we're actually doing both sides, but in the future, most of the government side will be on the roadside unit.
Are there any latency issues as far as depending on how fast the car is going?
No, the DSRC is very high speed, and if you're coming through an RSU, well, the range is about 300 meters, reliably. That's what they say. They can go much further, but 300 meters is a guaranteed range.
We actually need to wrap up, sorry, because the next speaker just has 15 minutes, so maybe y'all can take the conversation.
Yeah,
Yeah, thanks, sorry.
Sure.
Okay.